Hello everyone. So today we are going to be looking at the second question from Mathematics GC 2023, and the question says that the quadratic equation lambda x squared minus 4x plus lambda equal to 0 has real and distinct roots only when. So for this type of questions, there are some conditions that we need to know in order to solve them. So we need to be familiar with the discriminant of a quadratic equation. So we know that the quadratic equation is any equation of the form ax squared plus bx plus c equal to 0, where a is different from 0. And from this quadratic equation, if you want to get the value of x, if you want to look for the solutions of the quadratic equation, you generally use this formula: x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is a quadratic formula, right? This is used in getting the roots of a quadratic equation. Now in this quadratic formula, we notice that there is something special, right? Under this section, we realize that this formula kind of classifies our quadratic equation, right? We know that the square root of a negative number doesn't exist. So in a way, the formula under the square root sign will actually determine if this quadratic equation exists or not. So that's where the idea of the discriminant comes in, because the formula for the discriminant is simply this one in the bracket, minus 4ac. So it's simply that. And from here we have some basic conditions that we need to know. So when this discriminant is greater than 0, right, the square root of 0 is real, meaning that we will be able to get our solution from this quadratic equation. So when the discriminant is real, when the discriminant is greater than 0, here we have, this implies that we'll have real and distinct roots. These are the three equations, or the three conditions you need to know. When a discriminant is equal to 0, we have equal and real. They are equal and real roots. When the discriminant is less than 0, this implies we have complex roots or no real roots. So based on the format of the equation, you either be told that the equation doesn't have real roots, so in that case you use this condition. So from this observation, or from these three conditions, we can already eliminate option C and D, because it states that they are greater than or equal to 0, right? So it's already out, and you're left with 50% probability of selecting the correct answer, which is a great thing. So from here, we have been given our quadratic equation, this equation here, to be lambda x squared minus 4x plus lambda equal to 0. In this case, our a is lambda, our b is minus 4, and our c is lambda, right? We simply need to substitute the value of a, b, and c in our discriminant. And once we do that, we need to substitute this here. And once we do that, we're going to have b squared is negative 4 squared minus 4 into a is lambda, and c is also lambda. So we are going to have, so the condition that we're dealing with is this condition. So we need this to be greater than 0. So we have minus 4 squared is 16 minus 4 lambda squared should be greater than 0. So this is a condition. This is our answer. So we look at it, we see that the correct option there is option B. So option B is the correct value. Option B is the correct option. So you have to be extremely careful when substituting the values, because in some tricky questions, they will actually write it in the form something like negative 4x plus lambda x squared plus lambda equal to 0. and you completely could choose the wrong thing, right? So we have to be extremely careful to always rearrange it in the form of a quadratic formula, in this form, ax squared plus bx plus c. In this case, it wasn't complicated and it was already arranged in that formula, but always make sure you are aware about this. So with that said, we are done with this video. I'll be doing something similar for the rest of the equations. So if you're interested in getting solutions, like detailed solutions to the other GC equations, make sure to subscribe and just share this with someone if you know it's going to be beneficial for them, because you need to understand this in order to go for your GCE. Thank you so much for watching, and see you guys in the next one.